Hello class, welcome to Unit 4.3b, Measures of Dispersion. Should have watched yesterday's lesson, so I'm not going to talk too much here, other than to just kind of re-emphasize that when we look at the lower quartile, this is going to be our Q1. When we look at the upper quartile, this is your Q3. And when we do that interquartile range, that will be your Q3 minus Q1. All right. Pause here if you need to fill in the rest. Example 1 is going to be comparing your measures of central tendency with your measures of dispersion. So the following data represents the bullying scores of 9 students. Let's find the mean, median, mode, and range of the data. So let's pause here and make sure we put all of those numbers into list 1 and use our one variable stats. After we do our stat calc and one variable stats, we should be left with our mean, median, mode, and all these information below, where remember your mean is your x bar, which is really just your sigma x over n. So when we look at the numbers down here, we are getting the sum, which would be 835. Our number is 9 divided by 9, and ultimately those two numbers are giving us our average, or our mean, of 92.78. If we look for our median, it's going to be right there with a 93. And our mode, we need to look through our numbers, and we will find out that there are 285s, 297s, so we can potentially have two modes. All right, and if we take a look at the range, remember this is your max minus your min, your biggest number minus your smallest number. And we can find that two places. Right here, it kind of takes a little bit of the searching out, where we could look for that 99 minus 85 and get 14. Or if you want to take the minute, which in this case it looks like they're in order, so it's a little bit easier to find, but it's not always that easy. So a lot of times I like using that calculator. And lastly, not lastly, but would the range be used to represent the scores? Why or why not? Probably not, just because the range is just telling you the distance from the smallest to the biggest, how far they're spread out. It doesn't really have any representation. That 14 has no connection to what the actual scores were. It was just more of what's the range, or what's the highest minus the low. And lastly, when we're looking at the measure of central tendency, we are going to use this to essentially summarize the data. In other words, replace it. So what that's really just trying to find is one way to generalize, or kind of just say, all right, from 85 to 99, we were pretty much around a 92.78 if we want to use the mean, or 93 if we're going to use the median, which is always a good thing when we see those numbers kind of close together. Whereas as far as the measure of dispersion, this is going to be used to describe the spread in the data. In other words, how consistent are these numbers? This one's a little bit more consistent than the one we had yesterday. When we think about a 14 versus the 88, it's good to see that most people are between 85 and 99. Maybe not good for bullying scores, but we're playing pretty consistent as far as a range of numbers there. Example 2, using data to create a box and whisker plot. Answer the question. Now, before we do that, got to think back to yesterday when we say there are 6 things we're going to be looking for. We need the min, we need the max, or the min, lower quartile, Q1, median, upper quartile, Q3, maximum, which is your max x. So all that stuff in blue is what you're going to see in your calculator. And all of this stuff needs to be transferred into the box and whisker plot to the right. So we have our min, Q1, median, Q3, and our max values. Also remember, you will have to use that number line with equally spaced intervals and make sure all of that encompasses everything we need. And what this is going to also tell us is there's 25% in each section. Because we are splitting this data into 4 equal sections, that makes every part of this 25%. Because the median, that breaks it into 50%. And then when we do our quartiles, okay, that now breaks it into 4 even spots from our start to our finish. So 25% in each section. Take a minute to pause and put in these data's information into our calculator so we can calculate out our min, those 5 crucial values. What we should be seeing from our 5 key values, we should have that min of 0 up to a max of 25. So take a second just to write down those 5 key pieces of information, and let's put them in our chart. Now, something like this, from 0 to 25, what we're going to want to do on our number line is we're going to try to space that out. Now, 0 to 25, probably still don't want to count by 1s. 2s might be a little much, so I'm going to count by 5s. So if we start at 0 and then just try to count these out as evenly as possible. Right now, we're not going to be perfect. We're trying to hand draw everything. But if we have 0 to 25 as equally as possible, what we can then look to do is create our box and whisker plot. So I always like jotting each of these points down. Our 0. We have a Q1 at 3, so it's going to be something in that vicinity. Our median at 7. And our Q3 value at 22. And then our max at 25. So once you have those key 5 points, it's a matter of attacking this to make sure it's a box and whisker plot. I always like getting the whiskers first, and then that's going to leave us with a box for that middle, which is our interquartile, and then our median. So when we look at these, looking at this box and whisker plot, you can see it looks like our lower half is really scrunched up. Looks like the upper part is really spread out, looking at that range of values. Now, when we're looking at example 2 and trying to, now that we have this stuff graphed, and again, I would probably go back before we start answering some questions. Let's just put these values in. We got 0, 3, 7. We have a 22, and that was a max of 25. And that just might help us answer some of these questions below. So the interquartile range, remember that is Q3 minus Q1. Well, what was Q3? That looks like R22. Q1 was minus 3. So it looks like that is a range of interquartile range, highlighting that inner piece has a range of 9, or a spread of 19. Next question is having us look at the lowest 25%. Well, each one of those sections is the 25, so the lowest 25 is going to be down here. And that range falls between, looks like the lowest we had was a 0, and then our Q1 value was between 0 and 3. And then how many values are in each section? Well, if there's 25% of each value, and we are looking at 9 of them, 25% of 9 is going to give us roughly 2.25 per section. And part of that having a partial in there just comes from the fact that when we go to find our median is one of our numbers. But then when we go to find the middle of those next values, we're going to end up here and here with our 22 and our 3. And really, that's going to just kind of like we kind of looked at yesterday, that essentially becomes your box and whisker plot when they're in order like that. So that kind of helps make sense of why that value is going to be there. All right, let's take a look at the next one. Since this is day 2 of this, let's just have you solve example 3. Pause here, and then we'll come back for some answers. So first step is labeling the graph with our max and mins. The only one that looks a little unclear might be Q1 with 145. Should be something hopefully close to that. And then we have all of those things labeled to answer our questions. Well, the median, that's pretty clear that is going to be a 200. Our range, now keep in mind, range is max minus min, so we got to have to do 350 minus 50. So that's a pretty big range of numbers. Anywhere from 50 to 350 is going to give us a 300. When we look at our lowest 50%, well, think about the fact that all of these are 25%. And the lowest half would start from, basically the median down. So that means it would be anywhere from a 50 to a 200 would be our range of numbers for the lowest 50%. And then when we find the interquartile range, well, Q3 is going to be a 300 minus 145. So take a minute to do all that work. And we will end up with 5,255. Yep, 255. And then lastly, if there are 80 numbers in the data set, and how many are in each section? Well, this is where we're looking at 25%. That's the same thing as multiplying by a fourth, dividing by 4. So if we have 80 into 4 sections, that means we'd have 20 pieces of data in each section. Okay, let's take a look at the next one. Okay, looking at example 4, this is taking a look at some vehicles across the world. So looking at this box and whisker plots, what are 3 observations that can be made about the vehicle, about the miles per gallon? All right, I'll let you take a look at these, pause here, and work through. In this graph, we could make a lot of observations just kind of looking through. If we're looking at who has a question like the biggest miles per gallon, well, that's going to take us, max vehicle between, it looks like USA and Japan might be working with the best cars or most miles per gallon. So that may be one observation. We could also look at, USA on the other spectrum has a very low amount. We might take a look at the dispersion, where it looks like USA, again, has the biggest range from highest, max to min. It also looks like maybe France is pretty low. Now, what's going on over here with Sweden and Italy? We'll take a look at them later, but this looks like a pretty small range. The other two seem a little bit average as far as about the range of cars they can do. So we could talk about that. We could look at the fact that over here in Sweden and Italy, let's talk about that next. So if we look at 3 of them here, well, why doesn't that have any legs? Well, that might cause a situation where it looks like our median might be like 22, something like that. And who knows? We don't know. There could be a couple cars that are all around 22. But what that might mean is if we go up here to this other car, 25, well, maybe we have a whole bunch of cars that are 25 as well. And a whole bunch of cars down here at like 20 or 19 or whatever that number is, where basically your smallest numbers, when we find the middle, that would be like this 22 here, are basically our min and our Q3 all happen to be 19s, where this would be like maybe your Q3 and your max happens to be that same number. And as far as that Italy, where there's only one line, it's, we can either say they're all the same, or maybe there was only one card that they even have there. But, it could kind of work the same way, where if it's just a line, they're basically all the same. Or just maybe one card is all they make, without doing some more research. Other than that, we can, like I said, we can kind of look out there at some of our interquartile ranges. The USA, when we talk about our middle 50%, is spread out a little bit more, where you see France, Germany, Japan, Sweden. All those boxes seem to be about the same consistency-wise. Now, of course, Japan looks like it's averaging the highest, so they must make the most miles per gallon. So hopefully, after all that talk, you have at least 3 of those things that you had jotted down. Maybe if you have some other things, we'd love to hear from them in class. All right, other than that, have a good day, and make sure you finish the rest of your assignments.